explaining the properties of ionic substances. So high melting and boiling point, right? We've talked lots about melting and boiling point is strong forces of attraction between particles, yeah? Hardness, same reason. Substance will be hard if there are strong forces of attraction between them. What does that mean? It means that a large amount of energy is required to break those bonds or break those forces of attraction. Brittleness. When we look at our ionic bonding model of our alternating positive and negative ions, if I put a sharp force in particular, right? Sharp forces, it ensures that rather than just pressing on it, because if I just press on it, nothing's going to happen. But a sharp force, so whatever that might be, a hammer or something like that, we notice that the like charged particles align. And what do like charged particles want to do? They repel. So when you take a north end of a magnet and place it against the north end of the magnet, it repels, right? Same thing with an ionic bond. If we think about it also from a space filling point of view, right? So if you look there, right, and we try to push a layer of this across, notice that the chloride ions would actually overlap with one another. So that forces a strain within the ions, which further contributes to it repelling one another. So like charges align when a sharp force is applied, layer shifts across, like charges align, and they will repel, causing the crystal to shatter. Now, electrical conductivity. When in the solid state, the ions are fixed in the lattice structure. And what we need for electrical conductivity to occur is free moving charged particles. In a metal, those free moving charged particles are the C of D localized electrons. It's not electrons in ionic bonding. So in solid, there's no free moving charged particles. However, in molten, which means liquid, or aqueous, meaning dissolved in water, the ions have the ability to roll over one another. Therefore, they become free moving and they will move or migrate towards the opposite charged electrode. Does that make sense? Sort of. So it's not electrons in molten or aqueous solutions whereby the salt will conduct electricity. So it won't at all in a solid. In molten and aqueous it will. In metals, in all states, molten or solid. Yep. Only after they become melted. So if you're just heating it up, yeah, once you heat it to a liquid, those particles are no longer fixed in the lattice. So they become fluid, which means ability to flow. Yep. Yep. Yes. It's electrons in a metal. It's the ion that carries the charge. Yeah, so right, it's not electrons. So for example, in this diagram, I've got a circuit, electron flow in the conducting wire, so this would be metal. In the molten or aqueous solution, the nitrate ion or chloride, whatever it might be, carries the electrical charge through. So there's our summary. High melting temperature, strong forces of attraction. Brittle, like charges align and repel. Does not conduct electricity in solid, ions are fixed in the lattice. Conducts electricity in the molten or aqueous, ions are free moving. Our uses, right? So in building materials, it's used for hardness and strength. So similar to metals, the properties of a substance will help to determine a good use for it. So marble is a form of calcium carbonate, and we use that in building structures. Sodium hydrogen carbonate, or bicarb of soda, uses in baking and cleaning. Cleaning, as we react it with things like vinegar in a chemical reaction. In terms of baking, sodium hydrogen carbonate undergoes what's called thermal decomposition, producing carbon dioxide gas that gives you your nice fluffy cakes. Common salt, obviously, is used in cooking. We need chloride as part of our diet because it's the main constituent of stomach acids. Salt is a problem, so I guess this is extra and doesn't really relate. It's a problem because, particularly in Australia, whereby we used to have these natural floodplains. However, things like the Thredbo hydroelectric system has stopped the natural floodplains. We've had this buildup of salt resulting in death to plants because the salt concentration is too high.
Doesn't salt also contribute to the muscles and
Yeah. Electrolytes is really important. Too much salt, right? There are correlations between too much salt and things like diabetes. Too much salt, you can get stomach ulcers and so on. Again, this idea of extension, there's this really interesting stuff about salt in history. So in the 1850s in British-owned India, had this taxation on common salt in India. So come early 1900s, 1930, so this is Mahatma Gandhi day, is that 1930 was the salt march. So it was a resistance against taxation on salt and eventually led into the Indian independence. 1990s, we found that iodine, so iodine was found to be a crucial part of thyroid development and brain development. So it's really important that if you're putting salt onto your food, put iodized salt onto your food to get those small parts of iodine in your diet. However, when British presented this scientific data to India, there was resistance to it, right? Because they thought it was about British colonialism again coming in, and they saw it as propaganda. And that's it. Okay, that finishes us off in terms of the